Hello and welcome everyone. Today we are going to discuss an interesting topic of data science which is naive Bayes classification. Hope you like the previous video of my data science lectures. So now we are going to discuss naive Bayes classification in this video. Welcome to our deep dive into naive Bayes classification, a powerful probabilistic method for classification. So basically, to classify the equations or the data set, Naive-Bayes is very strong, in my opinion. It's a best probabilistic method and a powerful probabilistic method for classification of different tasks. Introduction to Naive-Bayes. Probabilistic method, simple and effective. Simple and effective, sorry, my bad. Probabilistic method. So let us discuss how it is a probabilistic method. Naive Bayes is a supervised learning algorithm that uses Bayes' theorem to predict the probability of a class given to a set of features. Simple and effective. It is very simple and effective. Despite its name, Naive Bayes is often surprisingly effective, particularly for tasks involving text classification and spam filtering. Bayes theorem. So basically, the Bayes theorem is divided into three steps of pyramid one, two, three. The first step is posterior probability, likelihood, prior probability. So posterior probability means the probability before probability, the probability of an event occurring given that another event has already occurred. So basically, the probability that is given to us of happening already is the posterior probability. Likelihood means the probability of observing the evidence given a specific time. Basically, you evidence what the task is given. You are watching that task. You are already evidencing that task. Prior probability, the probability of a class occurring prior to observing any evidence. So basically, before observing the evidence, the class occurs is called the prior probability. So basically, these are the three probabilities in Bayes theorem, naive Bayes theorem, that is posterior, likelihood, and prior probability. Now we will move to the next topic, assumptions of naive Bayes. So basically, every even a small theorem or a small procedure have their assumptions or the predictions in data science. So the assumption of naive Bayes are feature independence equal feature weights class prior probability. Feature independence, the algorithm assumes that features are independent of each other given the class. The algorithm basically assumes that the features are independent, the features are independent of each other, and the equal feature weights, all features are contribute equally to prediction regardless of their individual importance. So basically, removing the individual importance of every feature, everybody contribute equally in the importance of the algorithm. So basically, this is the equal feature weights. Class prior probability. The prior probability of each class is assumed to be known as estimated. Conditional independence, as you can see on the top right corner of the screen, A plus C is equals to basically the A, B, and C. So the feature A plus B and C. Features and classes. Features, basically features, attribute that describe the data such as words in a document or pixel in value in an image. Attribute that describe data. Basically the features. Features are what? Features are the attributes that describe the data, such as word in a document or pixels in an image. Classes. Categorize that the model aims to predict, such as spam or not, or different types of animals. Training the naive Bayes classifier, data preparation, probability calculation. For as we all know, this word data preparation will not leave you in data science, as this word is going to be the very first step of your every calculation, every basically the if you go through the data preparation will be going to be with you. So data preparation, the training of data is used to calculate the probability of each feature. Probability calculation, the algorithm uses the training data to estimate the prior probabilities of each classes and the conditional probability of each feature given in each class. Making prediction with naive Bayes. New data point, the algorithm calculates the probability of each class given the features of the new data point. Probability comparison, the algorithm assigns the data point to the classes with the highest probability. Basically, you can see the example here, as you can see on the screen on the right corner of the screen, classifying the data point, new data point, basically classifying in new mission. You can see there are many several, you can see the algo, basically the draw raw structure of this basically the new data point, the probability comparison. Here you can see the calculation classification is related to classification information mutation. So these are all basically the concepts of the making prediction by naive bias. Advantage and limitation of my naive bias. So there are as we all know that there are pros or cons of everything. So what are the disadvantage and the advantages of this naive bias theorem? Advantage: simple and efficient. It is very simple and efficient. It is very simple to implement. It is very efficient in time. Effective for text classification. Basically, the main raw thing of this naive Bayes theorem is it is very effective on text. Handle high dimensional data well, and it also handles the dimensional data that is very high dimensional very easily. Limitation: assume future independence. As we all know that it assumes the future independence. So if there is something dependent feature, if there is any dependent feature in the next upcoming feature, then it will be going to fail. Can be sensitive to prior probabilities. It can be also sensitive to the prior probabilities, maybe not perform well with the complex relationship between features. Application of naive Bayes classification: spam filtering, medical diagnosis, sentiment analysis. So basically these are some of the applications of naive Bayes. Spam filtering, classify emails. Or so basically we all have mails, we have checked mails. There is a section called spam section. By through the naive Bayes algorithm, we can classify the spam mails. How it classifies? It classifies through the text, the basically the text which is inside that implanted in that theorem. So it sort it by the text that it is a spam mail or not a spam mail. Medical diagnosis: predicting the presence of absence of a disease based on symptoms. Predicting the absence of a disease based on symptoms, basically predicted by presence or absence of disease based on symptoms. Sentiment analysis: determining the sentiment, positive, negative, or neutral, and pseudo. So basically this is all for today's video. Hope you liked the video. Hope you understood about the naive Bayes classifications, naive Bayes theorem, naive Bayes probability, and the applications of naive Bayes. So if you like the video, do give it a thumbs up. If you have any doubt, please please ask in the comments. Do like, share, follow, and if you like my videos, please subscribe to my channel. Thank you. We will be continuing this series more further. Till then, bye.